Okay, let's dig into this. We're looking at something really fascinating, maybe even a bit weird in AI right now. You see these amazing generative models out there, right? Doing incredible stuff, writing code, poems, making art. But here's the thing. The big puzzle, we built them, but we don't like fully grasp how they're doing it inside. What is going on in that black box?
Yeah, it's a really deep question
Yeah.
because, at a high level, we know the parts list. We know these big models are basically huge stacks of these things called transformer blocks. Think of them as layers doing computations. And their main job, predicting the next bit of text, the next token. They use that attention mechanism to figure out what parts of the input matter most.
Right. So we know the engineering, the components. It feels a bit like saying, okay, a brain has neurons, they fire. But that doesn't tell you how thoughts happen or consciousness. And that's the parallel here, right? What do all those internal layers and connections actually mean?
Exactly. What's the semantic meaning? And that leads us right into this wild idea of emergence. This is where it gets, frankly, pretty surprising. We didn't sit down and program these models step by step to suddenly be able to reason or translate languages fluently or write functional code.
We didn't teach them those specific skills directly.
Nope. But as they get bigger, specifically, somewhere between roughly 1 billion and maybe 100 billion parameters, that seems to be the range.
That sweet spot.
Yeah, that sweet spot of size and complexity. Suddenly, these completely new abilities just pop up. They emerge.
It's like they cross some invisible threshold and suddenly, bam, they can do calculus or something. And we don't really have a solid grip on why that scale.
Why that specific transition point? It suggests that just making the model bigger fundamentally changes how it processes information inside. It's not just more of the same.
It's a different kind of processing, maybe?
Could be. It's honestly one of the biggest open questions we have right now. And it really just highlights this gap, between being able to build something super powerful and actually understanding how its insides work.
Yeah, you can drive a car without knowing about internal combustion, sure. But if the engine sputters, you kind of wish you knew what was going on.
Precisely. Which brings us to this whole field, interpretability research. It's growing fast.
Okay, so what's the goal there?
The mission is basically that. Crack open the black box, figure out what's happening under the hood, try to understand what concepts live where inside the network, which connections matter for which tasks.
So like mapping the model's mind.
Sort of, yeah. Researchers are literally trying to find circuits inside these models, specific patterns of connections in math that seem to light up when the model thinks about, say, geography, or maybe when it identifies a person's name.
It sounds like digital neuroscience, trying to reverse engineer the model's learned algorithms.
That's a great way to put it. They sometimes call one approach mechanistic interpretability, finding the actual mechanisms, the algorithms, the model figured out on its own.
Okay, so why should, someone listening care about all this deep technical digging?
Well, that's the crucial part. It matters hugely for practical reasons. Think about AI safety. If we don't understand how it works, how can we be sure it won't develop some hidden, unwanted behaviors or biases?
Right, and trust. It's hard to fully trust something if its decision-making process is completely opaque, especially for important stuff.
Exactly. If AI is going to be used in education or hiring or, I don't know, even given legal advice someday, you want some assurance it's reasoning soundly. You want to know it's actually aligned with our values, not just mimicking patterns it saw in the training data without any real understanding.
So here's something to think about as you go about your day. We're relying more and more on these AI systems, right, for potentially critical things. But if we can't get a clear answer on why an AI reached a certain conclusion or how it made a specific decision, what does that really mean for our ability to trust it, to really ensure it's working for us in our best interest? That's the big question we're grappling with.